In first case, theta is angle between net component of both vectors and g vector. And of course tan theta is a by g, where a is opposite and g is adjacent. In second case, tan theta is g by a is wrong, and most of us go for it. So today I will be proving why it is wrong. So let us start with a diagram. I will draw perpendicular from this side and a perpendicular from here. So this is theta. Angle between two vectors is theta. So angle between the perpendicular vectors is also theta. You can also go for it in another way, where this is 90 theta. So of course this is 90 minus theta. And as this whole is 90 degree, so 90 minus theta plus what gives us 90 degree. So of course this is theta itself. Now in order to find tan theta, we need this one and this one. So we need components of g along this as well as this. So this is g, and we know that g upon h is cos theta, where h represents hypotenuse. So g sec theta is h. So vector along this direction is g sec theta plus this a vector also contributes in this direction. Here it is a cos theta and here it is a sin theta. Also g cosec theta is contributing in this direction. I will write it outside. Now we can write it as tan theta equal to opposite upon adjacent, that is g upon cos plus a sin whole divided by g upon sin plus a cos, and this will be equivalent to g plus a sin theta into cos theta upon cos theta whole divided by g plus a sin theta cos theta upon sin theta. Thereby we proved that tan theta is equal to tan theta. So this was proof for this triangle, and we need the similar proof for this one. Now if we suppose that this vector this is a vector, this is g vector. So we are supposing this is lambda 1 times a vector. That's what we do in vectors. This is a bigger vector than it, so this one is simply lambda 1 times this a vector, and this one is simply lambda 2 times g vector. So in this case tan theta is lambda 2 g vector upon lambda 1 a vector. Thus this is g lambda 2 upon a lambda 1 and not simply g by a. And these lambda 2 and lambda 1 are such that it makes this whole equated to a by g. So summarizing all the things, we come up to the point that it is the ratio of opposite and adjacent side that remains constant for given tan theta. And we cannot say anything about the opposite side or adjacent side. We cannot say anything about it, but just about the ratios, and the ratios are always constant for given tan theta. Similar is case here. This case is more genuine compared to this one, and I have proved it. You can simply assume this to be g equal to a and theta to be something else. So you cannot say that this is exactly equal to a vector and this is exactly equal to j vector. But you can definitely say that ratio of these two is equal to a by g. Similar is case in there. I hope you understood it.